Okay, so welcome back to this series on programming the Risk board game in C. So, like in the last episode, we had a look at the opaque point, like a opaque type pattern in C, which we've managed to do. The um, the point of this pattern is to avoid exposing your struct members and having sort of like expose a clean-ish API. I mean, like, is it clean? I don't know. That is in the eyes of the beholder to ascertain. So in this episode, I think well, so far what we've done is pretty much implementing the base infrastructure for playing a game, which is like, hey, we've got a game and we've got some players. Every game has players. There's just no such a thing as players. A game without player. So it was all pretty much generic, and we didn't really need to read the docs, but we're getting to a point where we actually do need to read the rules of the game. So it's basically so the game setup is like a bit involved. There are several steps to it, which makes it programming this quite interesting, actually, I think. So let's go and find the game. The setup instructions. So unlike most games, Risk demands careful planning before you actually start to play. The initial army placement sets the stage for the battles you'll fight later on. So select a color, and depending on the numbers of player count out armies you'll need to start the game. So in this episode, I'm thinking to do just that bit. So we've already done like the select a color stuff, and now we are going to need to implement that bit. So if we've got two players playing, see the instruction on page 11. We aren't gonna bother about that right now, because that sort of is a bit of a special case. But we are going to address player 3, 4, and 5, and up to 6 players, basically. So, all right, let's dive in then. Let's dive in. What do we do? We've got this test here. Game player registration closed, and I think this would be a place, because when you say, okay, cool, the game is closed for registration, we've got the number of players we want to play with. At that point, we should be able to initialize, to add those armies, available armies, to the players, to the players struct. So at this point, so we've got a game create, we add a player, which is a game black. We expect that the game is not ready to start, and we also expect that if there's only one player, it's not, there aren't enough players to play. And we add another player, and then we expect that, yes, the game is successfully closed for registration. I am, however, going to add one more player, because we want to treat the general case. And let's add so what did we have? We had add a player. So let's call this the black player. So yeah. That's going to be a player T, and that's going to be the black player. Player, yeah. Let's be explicit. And here we've got the red player, and let's add a blue. Oh no, I absolutely hate typing blue, and this is gonna be blue. Okay. I'm not going to bother checking for the return value. I'll just assume it works, which is bad practice, obviously. But yeah, let's do this. And then game. Oh, actually, do we want to do that? Yeah. Let's go on ahead and do this. So at that point, we should be able to expect equal black player, and we want to say player get available armies. So we'll have functions to tell us, hey, how many armies have you got available? And that should equal to the number 35 for 3. 35. Okay. I'm actually wondering whether this test is like really the right thing to do. I don't think it is, because we're gonna have to play like to add to test like the case for 3, 4, 5 up to 6. So I am tempted to write actually another test. Yeah, let's be nice and add another test. So we don't really care about naming this. We also don't care about that, do we? Yeah, and let's forget about that. Let's just rerun the test just to make sure we are good to go. And yes, I think we are. Oh yeah, there's one little things I wanted to do every time. I want to add this to my git ignore. Dot git ignore, and then anything that is a maybe under the src, just anything that is a .o object. Right, cool. Now it is gone. Actually, let me commit that. I'll just amend the commit from the last episode. All right, let's just push. And why that didn't work? Why is that? What is wrong with this? He's asking me to, okay, minus R, let's rebase that, let's pull. Okay, and let's select that, finish the rebase. Okay, we're good to go. Now should be able to push. All right, excellent. Let's just rerun the test, see that we haven't broken anything. Okay, sweet. So now we can go ahead with confidence that things aren't broken. So let's go back to our test. Let's create another test. Oops. Right. And then game with, how are we going to call this? Game with 3 players. A game with 3 players. Okay, let's go. When a game has 3 players, each player starts with 35 available armies. All right, that is a bit long, but this is my style. I like to write things just to avoid having like really. I like to have descriptive test names. Cool. So we create a game. We don't care about testing this. However, we are gonna close the game. So we're gonna add a player T, and that is going to be the black player. All right. We are going to add a red player. Oof, what has happened there? Red player, and then let's go white player. I think there is a white, right? White. Oh no, there's no such thing as white player. So let's go yellow. For sure, there are a yellow player, yes. Ooh, and yellow. Like this. Okay, then, all right, let's assert that the game is success. All right, and then let's go and then say expect equal game. I know that's player available. Player to get available armies. And that should return, and we would pass in the black player. All right, and then we should assert that this does equal to 35. Okay, that sounds good. Let's run our test. Oh, actually, let's do this and this for each of the for the red player and the yellow player. All right. Let's run the test. We do get our expected error, which is undeclared identifier this. So let's go ahead and add this to the header file, risk.h. Where are all the players function? They are here. So game, get player, game, and game at player. Player get color, yeah, okay, cool. And this is going to return a uint8 because I don't think you can uint8, the max number you can represent is 255. I don't think a player can really get like 255 armies. I don't think that's possible. So let's go ahead and get available armies, rerun our tests, and we get our undefined symbol stuff, which means we do now need to implement this function. And all right, where are the player get color? Okay, this file starts to be a bit messy. We're gonna need to address that at some point, but I don't think I'll do this in this episode. Player dot get available armies, and then we are gonna. So it's not payer, it's player. And then we would return, that's going to be player dot available armies. Do I want to make this our available armies count? Available armies? Maybe we do that so that it's obvious that it's that is a number rather than an actual struct or anything of the sort. I don't think we will implement armies as structs. I think it's perfectly fine to keep the count as numbers. At least for now, it works. Like if we need to modify that in the future, we will do that. But at the moment, I just want to implement the strictly whatever is necessary, and I don't want to have to code things which I'm not even sure I'm going to use in the future. So let's add this member to the struct. Actually, let's just run the test. It is not going to compile because, yeah, this doesn't exist on the player struct. So let's add this. Where's my player struct? It is above here, yes. Player. This is a player, okay. And let's add available armies to be a uint8 team. I think we actually don't need this because the struct is named after. And oh yeah, we do need to add that. Okay, yeah, we do need to add this, otherwise this player, otherwise this isn't gonna know what a player instance is. I get a bit confused with all these, like, do you name the struct before and after? Yeah, it's a bit confusing to me. I'll do some research and to enhance my knowledge about this, which is clearly now still a bit blurry. All right, it is now time to fix this as well and compile. And oh my god, that didn't work. It returned 0, right? Because when we initialize our player, we initialize the struct to be 0. And in fact, it's actually when we initialize the game, we calloc, we just allocs everything and then 0 out the memory. So that's normal to have 0, so that's fine. It works for now, but it is not the correct number. So the correct number, the way we're going to do this is like when we start the registry, when we do this, we want to calculate, we want to add this to our, we want to calculate the correct number of armies based on the amount of players there are in the game. So for this, I'm going to create a local function. It's going to be a static function, and static add players add available, players add initial, let's go initial available armies, and we should pass the game in. All right, and then game, and then what we need to pass. I think just the game is fine. And all right. This would be, I think this would return voids for now. Yeah, let's make this void. And let's call this function from our game here. And then pass in the game, and that's it. So, game, and then we should go... we should go over the list of players. And so the thing is, do we know? Yes, we do have the player count. So we can loop over all of the players array. Then do game. Let's create a for loop. That's going to be int. Well, actually, int 8t I is equal to 0. All right. And then when I is smaller than the game, player count, and then passing the game, we're gonna I++ this, and we're gonna go online game players, and we're gonna get the ith player, and we are going to, okay, yeah, okay. So let's store this player count, int 8t player count is equal to this. All right, that sounds good. And let's reuse that variable here as well. And then let's create another function that's gonna be, or shall we do, let's just do here switch case. Okay, so that's going to be a switch, player count. So you case 3. We will then return no, so K3 player count. Wait, no, so we are going to store this int 8 as well. Available initial armies count. Let's go available armies counts. I somehow misspelled that, obviously. I'm going to say is equal to 35. And I think that we then do a break here. Which, okay, that's good. And I think here we can do available, what was the name of our, it actually is like this, available army count is equal to 30, to initial available army count. All right, let's run our tests. Does it look good? No, it doesn't look good. So why is player get available armies not returning our thing? I would have expected that this would have been set by now, but it is clearly 0. What is going on here then? I am a bit confused. I'm very confused indeed, actually. Let's just make sure that we iterate over the okay player, and then %u. What is the modifier for uint? I forgot about that. So that is ud, no du, no su, us. Okay, let's just Google that the old school way. Uint 8t print f. That should give us is %u, isn't it? No, wait. What are they saying? What HU? The same format specifier. No. If you use %u and pass it, then the function converts that to an int and sign int. Okay, so that's just %u. Oh right, yeah. Like the warning was just like there wasn't enough argument to the printf function. That's just me being silly one more time. Okay, player 0. Right, this is interesting. So it looks like our player count isn't working properly. Okay, that is interesting. So if we go back to our test, let's do something simple, and let's do here we should assert that I think get player count, yeah, passing the game, and that should be 3, right? So that test should be failing now. And it seems that it is still failing on this. What is going on there? Okay, so that's good. Let's just have one assertion for now. I is equal 0 plus I. Actually, let's just make this I plus plus. and player count, game of players. All right, let's put a printf back in there, and then that's gonna be player. Let's print the pointer here, \n, and let's go and get the address of this player, and let's also %u this, and then say add the and print the I here. Let's see what's going on there. For the semicolon and so we still have. All right, so what is player count here? Okay, player count. Ask me that person's you. And oh yes, of course, I need to also add the player count there. All right, and let's run this. So where's our print statement? Oh, player count 1. Now this is very interesting. So we create a game here. We do this, and player to get available armies. Oh, wait a second. I believe. So game registration close. Okay. That's being called here, and it is successful. So you could assume then there it goes here, pass the game in, and then call this. All right, let's say, let's add some more debug statements and game, and then what that be, player count. Right, yeah, I really can't type. It's Sunday, people. I'm still not quite awake. And let's go game player count. Right. Oh, it's true that we have this. So let's cast this to our struct game instance pointer. Okay, and then let's do %u. Oh, right, it's still not happy about something. What is the error? Let's have a look. Yeah. Struct game T. Oh, right, yeah. I need to wrap this in parentheses. Yes, okay. Otherwise, he was trying to cast this to that, which isn't obviously right. All right, what do we have? Player count 1, player count 1. Oh yeah, I'm being silly. So this returns, yeah, player count 1. Huh. Okay, all right, let's do some more debugging there. Let's print here. What the hell is this pointed to? Test game. Let's go and let's print its pointer and pass the game in. All right, and then here as well. Let's actually print whatever the game is that is being passed there. %p, And let's just remove the casting, reuse that, and there you go. Let's run the tests. So this is indeed. Oh, this is not pointing to the same. No, wait. Hang on a second. Oh, that is the player. The test game. Oh, right. It is not the same game instance. 30 4120, and then here it's 4110. So somehow, somewhere, my game instance has changed. Why? I don't understand this. So I am calling this here, game registration close. Game player count is equal to 3, so we know that works. But this doesn't work. And somehow game player count. Okay, that's interesting. Game player count. Return game success. Oh, wait a second. If the game player count is greater than 1, then you do this, and then oh yeah, you never call this. Oh, you only call it once. Okay, cool. I get it. I get it. So what was happening is that I'm calling this function not in the right place. And that is because this function is perhaps slightly confusing. So I'm handling the special case. Instead of handling the special case where there's not enough player before, like in a guard close, I do actually I actually mark this. So I think it would be maybe a bit less confusing if I were to actually reverse this condition and like make this smaller than 2, and then return like this. I think this wouldn't have tripped me up. It's also because, you know, it's Sunday. I'm running low. I'm not yet there fully, so apologies. This should actually not work now, I believe. Let's just run that. And yet it does work. Yes, you can see that it's doing its job. Wonderful. There you go. If we can remove that and do that. Okay, this is great. And we do have our little. Now we do have our the correct amount of available player. Right, let's now basically duplicate this setup, and also with 3 player with 4 players, we should have not 35 but 40 armies. Let's add another player here. So let's go with the green player. Right, and that should be then 40 here. 40, 14. And also let's add the green player. Actually, no, it's not 40. It's going to be 30. It is going to be 30. Apologies, 30. Let's go back to the verify there. Yeah. Yes. The more players you have, the less infantry you get, obviously. infanteries, armies, infanteries. Right. So that should be equal to 4, and then here that should be 3, no, 340, but then 3 and 3. That is the green player. Yeah, we've got all our players there. Right, that didn't work because we need to add another case here. So like case 4. We want to do this and then do 30. Right, run our tests. Wonderful, that works. And right, let's duplicate this. Let's add then now the pink player. Right, and let's also add the pink player there. Oh, what have I done? I don't know what that is. I've just hit like a special shortcut, and it's somehow highlighted everything. All right, and then pink, let's run that. Ooh, that didn't quite work. What is wrong with this? What is wrong with it? What's this error? Redefinition. All right, yeah, because I've lazily copied things, and then that's going to be with 5 player, and that should be 25. Right. And there is an error. Oh yes, because we now need to also add this special case 5, and then 25. And it doesn't work. Whoa, what is going on here? Got the game like pink player. Oh, this red thing is annoying me. I'm just gonna reopen the file so it disappears. Yes. All right. Oh right. Well, no, not 20. That's gonna be okay. Let's just do a search and replace. Replace 30 with 25. Yes, all the instances. And okay, this works. Let's copy this test. This isn't ideal. We could make a little test helper that says, hey, create me a game with this many players. However, I think it's quite handy to have the test set up like right in front of your eyes to understand the test. And those tests aren't like super big either. And they're sort of like unit test type of things. So let's go with 6 players, not 60, and that should be 20 players. Now, a $1 million question. What is the, I think it's blue. Yeah, it is blue, because I absolutely hate spelling blue. Is that how you spell blue? That is not how you spell blue. Is that how you spell blue? Yes, that is. BLUE. Right, and let's also add the expectation for that blue player. And of course, I've misspelled it. Right, there you go. Now it isn't going to be get available armies, and then that's blue that I need to replace. And because in French you start to spell bleu, you spell it B-L-U-E. B-L-E-U-E. So my muscle memory. Okay. I am going to replace this 25 with 20. Right. Oh my god, that didn't work. Okay, that works. And the game should not have 5 players, but should have 6 players. What is wrong now? Okay, yeah, that is now because we need to add our special case statement. Let's go 6. And oh, well, yeah. So I also need to remove that, and we're good to go. This is working for us. I think. What will we have left to do then after that? After that, we're gonna need to then implement something interesting actually, which is gonna be the roll die thing and like random algorithm. But I'll do this in the next episode. I think this is gonna be interesting. Because we're gonna go the simple route, just using the like leapsy just math random function. However, it's not like considered as super safe. Like truly, like it's not like the best randomness that you can get. But there are some safer alternatives to that, and one of them, I believe, would be the OpenSSL library. So maybe that's going to be an opportunity for us to learn about that. That should be an interesting episode. That is yet to come. I will work on this this week, prepare that, and then hopefully soon enough, I will have this ready for you. And on that note, I will say everyone goodbye and see you in the next episode.